All right, this is a mini lecture on balancing chemical equations. First of all, what is a balanced chemical equation? Well, one of the foundational pieces of chemistry is that matter cannot be created or destroyed in a chemical reaction. So if we look at a reaction like hydrogen reacting with oxygen gas, yielding water, according to Dalton, all matter cannot be created or destroyed in a chemical reaction, so all matter has to be accounted for. So in this reaction, this is called a chemical reaction. We have hydrogen gas reacting with oxygen gas, forming water. So if we start off with 2 atoms of hydrogen on the reactant side, which is this side of the equation, these are the reactants, then we must have 2 atoms of hydrogen on the product side, always on the left-hand side. This arrow here is called a chemical yield sign. Sometimes you'll see it this way, or if the reaction is reversible, sometimes you'll see double-headed arrows like this. But for us, we're going to keep them all going 100% in the forward direction. So we can see that there's 2 hydrogens on the reactant side and 2 hydrogens on the product side. But we have a problem with the oxygen. We have 2 oxygens on the reactant side, but we only have 1 oxygen on the product side. So you may be thinking, well, why don't we just put a 2 here like that? Now we got 2 hydrogens on both sides and 2 oxygens on both sides. The problem is this is no longer water. H2O2 is hydrogen peroxide. It has totally different chemical and physical properties than water. So we can't change the subscripts. If you change the subscripts, you change the chemical compound. So what we can do is we can put a 2 in front of the water, and that's called a coefficient. What this is in essence doing is it's saying that, well, we've got a hydrogen molecule here, and we've got an oxygen molecule here, and over here on the product side we have a water molecule. All right, so by saying 2 here, now we have 2 water molecules. All right, so the oxygen problem's been settled. There's 2 oxygens on the reactant side, and now there's 2 oxygens on the product side, albeit in different form. Over here it's oxygen gas on the reactant side. It's a gas that we breathe. It's clear, colorless. Over here on the product side, the oxygen is now combined with hydrogen to make water, H2O. But now we have a problem on the reactant side. We have only 2 hydrogens on the reactant side, and we have 4 hydrogens now on the product side. So we're going to have to put a 2 in front of the H2, the hydrogen, to make sure that we have the same number of hydrogen atoms on both sides. So our equation's balanced at this point. There's 4 hydrogens on both sides of the chemical yield sign, and there are 2 oxygens on both sides. Now, according to Dalton, again, matter cannot be created or destroyed. We know that each one of these hydrogens has a mass of 1 atomic mass unit. And we know that each oxygen has a mass of 16 atomic mass units. So we've got 1 times 4, we've got 4 atomic mass units worth of hydrogen, and 16 times 2, we have 32 atomic mass units of oxygen. So if 100% of this is consumed in the reaction, we lose all 4 atomic mass units of hydrogen, and we lose all 32 atomic mass units of oxygen. Then that mass should be accounted for. All 36 atomic mass units should be accounted for on the product side. All right, well, let's see if that's the case. Let's find out how many atomic mass units this water weighs. Well, it's 1 for each hydrogen, and it's 16 for the oxygen. If we add that up, that's 18 atomic mass units for that water, and 18 atomic mass units for this water. If we add that up, that's 36 atomic mass units. This is a really important concept in chemistry because before Dalton, people believe that things did vanish, things did disappear. They saw things burn and they saw that solid go away, but what we now know is that other substances are formed. Maybe they're clear, odorless gases that we can't see. So nothing vanishes or disappears. All matter has to be accounted for in a chemical reaction. And that's the basis of balancing a chemical equation. Let's look at another example. Now, I'm not asking you in Chemistry 120 to be able to tell me what the products are, except for this reaction. I do expect you to know that anytime you burn a hydrocarbon, that's a carbon-hydrogen compound, and oxygen, that the two products that you will always get is carbon dioxide and water. This is complete combustion. Now, there is also incomplete combustion. In that case, you may get carbon monoxide instead of water, and that's why it's a serious problem to burn propane in your house or garage or barbecue in your garage with charcoal, because you can generate carbon monoxide, and it's, again, a silent killer. It doesn't have smell. It's clear, and so you see people that succumb to carbon monoxide poisoning every year. But this is complete combustion, and so I just want you to remember that anytime you burn a hydrocarbon and pure oxygen, the two products that you always get is carbon dioxide and water. So the first thing you need to do is, let's think about balancing the equation. Well, what I generally look at is I look at the most complex substance, like this C3H8, which is propane. It has both carbon and hydrogen, and the carbon and hydrogen are different in different compounds on the product side. So right off the bat, I know I need a 3 in front of the carbon dioxide, coefficient of 3. That gives me 3 carbon. Now that also affects the oxygen. Now I have 6 oxygen, but I'm not going to worry about that just yet. The next thing I want to balance is the hydrogen. There's 8 hydrogen on the reactant side. So I need to put a 4, coefficient of 4 in front of the water. Why did I do that? Because 4 times 2 will give me 8 hydrogen. So I have 3 carbon on both sides of the chemical yield sign, and 8 carbons on, or 8 hydrogens on both sides of the chemical yield sign. So the only thing I need to balance now is the oxygens. I've got 3 times 2 for carbon dioxide here. 3 times 2 is 6 oxygen, plus 4 times 1. That's a total of 10 oxygen on the product side. And so I look on the reactant side, I only have 2, so that tells me I need to put a coefficient of 5 in front of the oxygen on the reactant side. Let me clean that up just a little bit. That gives me 10 oxygen. Now, if you're having troubles keeping track of all this, just say carbon have 3, hydrogen have 8, oxygen, write it as O. You have 5 times 2, you have a total of 10 on the reactant side. Check on the product side. Carbon, you have 3. Oxygen, you may want to say 3 times 2, 6, plus the 4 here is equal to 10. And then the hydrogen, you have 8. So the equation's balanced. The only way you get good at balanced chemical equations is doing a lot of them. I hope you're doing the ones in the book, and you can check your answers for the odd ones in the back of the book. But remember, you can't change the subscripts. If you change the subscripts, you change the substance. All you can do is change the coefficients. Now, one of the questions a lot of times that I ask on an exam is, what is the sum of the coefficients when in the correctly balanced equation? Don't forget that in front of the propane here, there is a 1. We just don't write it. It's understood that if it's in the chemical equation, there must be at least one of them. So if someone asks you what the sum of the coefficients are in your balanced chemical equation, for this particular reaction, it would be 1 plus 5 is 6, 6 plus 3 is 9, 9 plus 4 is 13. So my answer would be 13. A lot of times what I see on the quiz or exam is people add the 5 plus the 3 plus the 4, and they say 12. but you forgot to say that there's a 1 in front of the propane. I hope this helps, and if you need further information, let me know. Thank you.